in this video, we want to look at limit of some special functions, all right? Good. Okay, so these special functions are based on trigonometry anyway. We have the limit as theta tends to 0 of 1 minus cosine theta over theta. Well, right here, we have a basic tool to make use of. We have the limit of this function sine a over a as a tends to 0. That the result of that limit is going to give us 1. So what this notation here tells us is that whenever we have sine of some angle divided by something, now you observe that the angle and what we have on the denominator, they are the same, right? Then as the denominator tends to 0, that the result of this limit, all right, is going to be equal to 1. So that's just what we're going to make use of anyway. So whenever we see sine of something divided by that same thing, the result is going to give us just 1. Okay, great. So let's look at the first question. We have limit as theta goes to 0, all right, of 1 minus cosine of theta divided by theta. Okay, so let's just do this by substitution. We plug in what theta is approaching into that function. So if theta is approaching 0, you're going to have cosine of 0, which is going to be 1. So in the numerator, we're going to have 1 minus 1. Since cosine 0 is just 1, then the denominator is going to give us, as theta is approaching 0, theta will be 0 here, all right? So we're having 0, 1 minus 1 is 0. We're having 0 over 0, which is an indeterminate form, right? So when we have such results, we do not want it. So we have to go ahead and do more work on the function in order to get a meaningful result. Good. So this is 0 over 0, which is an indeterminate form. So this kind of result is not needed, all right? Good. Great. So let's go ahead and look at the function part only. So let me deal with the function and try to, let's say, rewrite it, all right? Let me just rewrite the function by doing some basic operations on it. Okay, so what I would like to do here is to multiply the numerator and denominator of this function by the conjugate of the numerator. So the conjugate of the numerator will just be by changing the sign between those two terms, all right? So here we are having negative, so I'm going to multiply with the positive version, and I'm going to do that to the top and the bottom. So this is it. Multiply the top by 1 plus cosine of theta, and then do the same thing to the denominator, right? And multiply the denominator by 1 plus cosine of theta. So this kind of multiplication is called multiplication by 1. Okay, so let's expand the numerator. We're going to have 1 minus cosine squared theta. When you do the expansion in the numerator, that's what you're going to enter with. And then the denominator, we just have it to be theta times 1 plus cosine of theta. And now, well, we know of a trigonometric identity that tells us that cosine squared theta is equal to 1. That tells us that cosine sine squared theta, okay, if you want to make that subject of formula, you'll be having 1 minus cosine of squared theta, right? So with this equation, you can get to this second equation. Okay, so in the numerator here, we're having 1 minus cosine squared theta, which is said to be sine squared theta, all right? So in the numerator, we just enter with sine squared theta, and then we have it to be theta times 1 plus cosine theta, right? Now, I'm going to rewrite this further, and I'm going to do some rearrangement here without changing things a lot, all right? Now, this is how I'm going to write this, taking note of this fact. So we're going to have sine, I'm going to split this sine into 2, okay? Sine theta times sine theta will give us the square, all right? So this is sine theta over theta, all right? Let's just say I'm going to split the fractions as well, times this other sine, theta over 1 plus cosine of theta. Good. So if you multiply these two fractions again, you're going to enter with this. All right. So as I said earlier, let's keep the function and rewrite it a little bit. Now that I've reached this point, maybe I can now put down the limiting notation. So the limit as theta tends to 0 of the product. Okay, so you know that the limit of the product is the product of the limit. So let's just evaluate it immediately. That's what we've got. Now, we have sine theta over theta. As theta tends to 0, the result is going to be 1, all right? Because that's what we get from this rule when this and this are the same. So in this case, we are replacing the a's with theta. Okay, so we take the limit again as theta tends to 0 of this other fraction. Well, sine theta, as theta tends to 0, the result is going to be 0. Then the denominator we enter with, as theta tends to 0, this will be 1 plus Cosine 0 is 1, so that's going to be 1 plus 1. So we're going to have 2 in the denominator. So this is 1 times, well, since we have 0 here in the numerator, 0 over 2, the result is 0. So 1 times 0, the result of that limit is just 0. All right? Good. So that means that the limit of this function, as theta tends to 0, is equal to 0. All right, great. Okay, in our next video, we're going to look at the limit of this second function, the limit as x tends to 0 of tangent of x over x. All right? Just to reduce the length of this video. All right, great. Okay, thanks for watching. Please subscribe to my channel.